Hi, let me now introduce to you the other conic section known as parabola. A parabola is the intersection of a right circular cone and a plane that is parallel to an element of the cone. Referring to the figure on your screen is a right circular cone. Now, if we pass through a plane where this plane is actually parallel to the element of the right circular cone, the plane will cut through the cone and will have an intersection which is in the form of a parabola. Now, referring to the definition on the screen, a parabola is a set of points on the coordinate system that are of equal distance from a fixed point and a fixed line. The fixed point is called the focus, and the fixed line is called the directrix. Okay, and then the line that is connecting the 2 points on the parabola and passing through the focus is called the latus rectum. The axis of symmetry is the line which divides the parabola into 2 equal parts and passes through the vertex and the focus. Now, let me show to you a diagram showing the figure that is provided in the definition. So, let's say you're given a Cartesian plane. So, we have here your x and your y axis. Say, the parabola form passes through the origin. Okay. Now, by looking at the definition, it is defined as the set of points in the coordinate system that are of equal distance from a fixed point and a fixed line. So this is now the set of points defined in our given definition. So all the points here should be equidistant from a fixed point. Say, let's denote this as F, which is our fixed point, or also known as the focus. And this set of points are all also equidistant from a fixed line, which is called directrix. So if we draw that fixed line to be placed here, so this is called your directrix. So if you get a point P on the set of points and find the perpendicular distance with the directrix, and then get the distance of this point P from the focus, so you should note that this distance P to F should be equal to the distance from P to D. That is by definition. Okay, so the set of points is defined here. The focus is located here, and then the directrix is just below the vertex. So the vertex is actually the lowest point on the graph. Let's say the parabola is now placed in a Cartesian plane having its vertex as point 0, 0. And then, say the distance from the vertex to F would be the distance P. Therefore, the coordinates of F will be 0, P. Right? Okay. Now, if you draw a line perpendicular to the y-axis passing through the focus, we will have this chord. And the chord will have these two intersections on the parabola. Now, if we measure the distance from endpoint to endpoint of the chord, the length would be equal to 4p. So if you measure this is the distance between vertex to focus to be p, just multiply it by 4. That will be the total length of this chord. Okay, the line that passes through the focus and is perpendicular to the y-axis is also known as your latus rectum. So it has a Latin name, latus rectum, where the word latus means length, rectum means opening. So it's basically length of opening of your parabola. And you have to note also that the distance of the vertex from the directrix is also p. Okay? Do we have any question on the diagram? Okay, now going back to our definition. The line connecting the 2 points on the parabola passing through the focus is called the latus rectum, so we're clear on that. And the axis of symmetry is the line which divides the parabola into two equal parts and passes through the vertex of the focus. Now, the axis of symmetry is actually the y-axis in our case, since the line passes through the focus, the vertex, and the vertex. The line is actually perpendicular to the directrix. Now, let's go to the standard form of the equation of a parabola. The standard form of the equation, if a parabola with vertex 0, 0, of a parabola with vertex 0, 0 is given by x squared equals 4py, or is actually given by y squared equals to 4px. Okay, let us consider an example to illustrate that given. Let's try to work with other example other than this. Say we are given 8y plus x squared equals 0. Okay, the equation given is actually not in the standard form, because if it is in the standard form, the equation should be x squared equals 4py or y squared equals 4px. So that must be in the general form. So given an equation of a parabola in general form, we'll transform this into the standard form. So we just have to transpose 8y to the other side, so that you will have x squared is equal to negative 8y. Now the standard form of a parabola is equal to x squared equals 4py. That is coming from the definition. So we have here this part of the equation. So you'll have negative 8 equal to 4p. And then we can actually solve p in this case. So we'll divide 4 on both sides of the equation. So it shows that p is equal to negative 2. So what actually is this value? Okay, the value P is negative, and we define the, P to be the distance from the vertex to the focus. So a negative sign means, or it refers to the direction. So if P is negative, that would mean P must be below the vertex. So to show you the diagram, let me draw the x and the y axis. The vertex is at 0, 0, and the focal distance is 2 units downwards. So you get 1, 2. So our F is at 0, negative 2. Now, the focal distance and the distance of the vertex from the directrix should be the same. So you should just measure 1 and 2. Positive, right? So that would mean this is the location of our directrix. Let me just... Okay. And the equation of the directrix is actually y equals 2. So it's the horizontal line, y equals 2. Now, what else should be determined? Other than the focal distance, we need to identify your latus rectum. Our latus rectum is actually the distance 4p, or the absolute value of 4p. So 4p is actually equal to negative 8, right? So that the latus rectum is the absolute value of negative 8, which is equal to 8. So that would mean if you divide 8 by 4, that would be the distance from the focus to one of the endpoints. So you got 1, 2, 3, 4. You got 1, 2, 3, 4. So you draw the line here. That's positive 4. This is negative 4. And this is your focus. So the one of the intersections is here. The other one would be here. So the endpoints are with coordinates 4, negative 2, and the other endpoint is negative 4, negative 2. Now to draw the parabola, you just have to connect the endpoints of the latus rectum and the vertex. Okay, so we now have the graph of your parabola with vertex at 0, 0, focus at F, 0, negative 2, endpoints of the latus rectum are 4, negative 2, and negative 4, negative 2, and you got the directrix. So these are actually the features or information that you need to determine so that you'd be able to plot the graph of your parabola. Any question on the first example? Okay. Let me have another example. Say you're given x squared, say minus 4y equals 0. It's actually in the general form. So to transform this in the standard form, you just have to transpose 4y on the other side. So you'll have x squared to be equal to 4y. Okay, now the standard form is x squared equals 4py, right? So you just have to identify 4p. Our 4p is actually equal to 4. And then we divide both sides by 4, so you'd be able to determine the value of p, which is equal to 1. So this is your focal distance. Okay? So p is equal to positive 1. So what does it mean? This time, if we draw the line or the parabola with vertex at 0, 0, and focus must be 1 unit, it should be above, right? So it will be 0, 1. What's the value of 4p? 4p is actually equal to 4. You get the absolute value, so it's actually 4 units. So that would mean 2 units to your right and 2 units to your left to get the endpoints. 1, 2, 1, 2. Are you following? So what are the endpoints here? This is 2, 1. This is negative 2, 1. Connect the points. You'll have your parabola opening upward. The directrix is actually 1 unit from the vertex. Okay, this is your directrix. So what do you think is the equation of the line? That should be y equal to 1. So we now have the graph of your parabola. So we have the general form, and you're able to have it in the standard form. Okay, question regarding these 2 examples. So the difference between the 2 examples is that the given here is equal to negative 8ay or 8y, and the given here is equal to a positive value or 4y. So that would mean if you have a negative value of 4p, it should be opening downward. If your 4p is positive, it should be opening upward. Take note of what is squared in the equation. X is a second degree, or is of the second degree. So that would mean the axis of symmetry would be the y-axis on both example. So what do you think will happen if the equation given will have a y that is of a second degree? So if y is of the second degree, most probably the axis of symmetry would be the x-axis. So again, the opening of the graph would either be opening to your right or opening to your left, depending on the value of your 4p. So if 4p in y square is positive, graph should be opening to your right. Okay? Then if 4p is negative in y square, then it should be opening to your left. Okay? So I'd like you to contemplate and study the examples given, and I will let you work on some of our examples. Okay? So I guess that would be for today, and we'll have more of this in your next session.